All right, gang, let's work on section 1.5. We'll be going over the practice problems. We are going to be talking about special angle pair relationships, reminding you about our goal for this lesson. We are going to identify 5 new or different special angle pairs. What I'm going to do now is pause the video and get to the practice problems. Make sure that you have your goal copied here, and then I will catch you in a minute. All right, these first practice problems are going to be specifically focusing on naming angles. And here we're going to be talking about the different kinds of angles that we have. The first one that we're going to talk about here are the adjacent angles. Remember, those are the angles that are next to each other. They are neighbors to each other. They have a common vertex and a shared side. They oftentimes are the hardest to identify because they don't have a number that goes with them. But let's work on these here. The first thing I want to do is I want to number these angles, angle 1, 2, and 3, and that will just help us do our naming a little bit easier. To point these out here, so angle 1 is this angle right here on the left. Angle 2 is this angle in the middle, and angle 3 is this guy right here on the right. So between those 3 colors, which 2 colors are next to each other? Well, the first one that I would notice would be angle 1 and angle 2. Thinking about our definition, we have to have a common vertex and we have to have a shared side, and angle 1 and angle 2 are each on one side of that blue line. That makes them adjacent angles. The other pair that I notice is angle 2 and angle 3. They are next to each other with this shared side and a common vertex. Angle 2 and angle 3. If you look at angle 1 and angle 3, those are not adjacent because they have that green angle 2 in the middle, and so we take those out of the mix. Then let's move on to supplementary angles. Remembering that those are angles that add up to 180 degrees. Remember, we took this S right here and we drew a line on it and turned it into an 8, and that helped us remember, hopefully, that the definition of supplementary is 180 degrees. Now, for 180 degrees, in this diagram, we have to think a little bit differently. We notice that angle 1 and angle 2 together could be thought of as one angle, and to name that, you can't use angle 1, 2. You actually have to use letters for that. So that would be angle HIK. Noticing K is in the middle, and I is in the middle, and I is my vertex. Then what angle would you put with HIK? That would be this other angle on the other side, and that would be angle 3. We could name that using letters. We could use KIL if we wanted, but again, it's just all by itself, so we can call that angle 3. The other thing that I notice in that diagram is the right angle. And what I'm going to do is erase everything so that we can focus on this box right here. Do you see that the 90-degree angle is on the right-hand side? Ignore this ray right here, and you have a 90-degree angle. What can you put with 90 to make 180? Well, that would be another 90. That means that the left side also has to be 90. So if we wanted to name the left-hand angle, we would call that angle HIJ, which we did have an angle 1 right there. And we would pair that with angle JIL. That was our angle 2, 3. Those are the supplementary angles. If we jump over to the other side and look at complementary angles, we're thinking that those are angles that equal 90 degrees. Remember, we turned that C into a 9 when we drew our line, and that's how we can help remember that those are 90-degree angles. So in this case, we're looking for two angles that add up to 90 degrees. Again, we have the box right here, and that looks like that would be a 90-degree angle, CBE, but it's not complementary because complementary has to be two angles. So this line right here is what divides it. We can name those two adjacent angles as our complementary angles. We would call that angle CBA. Middle letter is B, vertex is B, and angle ABE. Again, middle letter is B and vertex is B. The other two angles that I notice that add up to 90 degrees would be this 75 and this 15. So to name those two angles, again, we would be talking about angle CBA. Trace that out, C to B to A. That's the angle in the middle. And angle G. Again, we can call this a single angle G because there is only one angle there. We could also call it HGI. Those are complementary angles. Now I'm going to have you pause, and we will move on to the next page, page 2. On page 2, these practice problems, and kind of in the middle of the page here, we're going to be talking about identifying angle pairs again. And we're talking about, in this first problem, A and B, two specific kinds. Remember, the vertical angles, those are the ones that point at each other, or some people consider them opposite angles. They are formed by two intersecting lines. The linear pairs, those are a pair of angles that make a line. That's two angles on a line. So let's look for those. Let's first identify some of our angles here. So we have these all numbered. Notice there's no letters. We're going to use our numbers. So we have angle 4 pointing at angle 6. Noticing these two straight lines that intersect each other. That makes angle 4, 4, and angle 6 vertical angles. Some might argue that angle 5 and angle 3 point at each other, and that would also be correct. There are two separate answers for that question. When I look at angle 1 and angle 2, they are not pointing at each other, they are just next to each other. Which brings us to the linear pairs. Linear pairs have to be two angles on a straight line. If you notice here, we have a straight line. We have two angles, angle 1 and angle 2, that are on that straight line. If you look even deeper into the question, you'll notice that you have more straight lines. And here we have angle 3 and angle 4. Or you can look at angle 4 and angle 5. Or you can look at angle 5 and angle 6. Or you can even look at angle 6 and angle 3. All of those would also be considered linear pairs. Now what I'd like you to do is pause this video and jump down and see if you can answer the questions at the bottom of the page. We've talked about all the different kinds of angles, and see if you can get those. All right, let's look at this last chunk of, or this chunk of problems, C, D, E, F, and G. All of these are special. I do want to talk about this question right here real quick. It says, which special angle pair does not have a number relationship? So which one of these definitions doesn't have any number that goes with them at all? And I do know that linear pairs, because they make a line, they have to add up to 180 degrees. And let's see, complementary, if we go down here, remember we turned that into a 9. Those have to be 90 degrees. Supplementary, remember we turned that S into an 8. That was 180 degrees. That leaves vertical and adjacent, and how are those guys related? If you remember, we mentioned in our notes that vertical angles are always equal to each other, so whatever number one is, the other is. It turns out that adjacent angles are simply next to each other, and there is no number relationship, so that guy right there is adjacent angles, and I think sometimes that's why it gets to be a little bit tricky for people, is because there is no number that you put with those. They're just automatically next to each other. So I have filled in some of the answers here. Let's see how you did for a linear pair. All right, for the linear pairs, I have angles 4 and 5 named. If I look at angle 4 right here and angle 5 right here, this angle and this angle right here, I can see that they do indeed make a straight line. So that seems like a good one right there. Then for vertical angles, I actually said that there are none of those. Those, remember, are the ones that are formed by straight lines, and so I have this straight line, but there's no other straight line that X's all the way through that to make angles that point at each other. So in this case, there are no vertical angles in that picture. The adjacent angles, those are the ones that are next to. Oftentimes, that is the one that has the most number of answers. And in this case, I listed all of them. Angle 1 and angle 2, those guys are next to each other. Angle 2 and angle 3, they are next to each other. Angle 3 and angle 4, they are next to each other. Angle 4 and angle 5, they are next to each other. Oh, I missed one. Angle 1 and angle 5, they are next to each other. Those are all of our adjacent angles. Then the next one that we're looking at were the complementary angles. Remember, complementary are the ones that add to 90 degrees. And the one thing that's nice about 90 degrees in a lot of pictures is you get this little box right here. So there's your 90. That means that angle 3 and angle 4 have to be 90 degrees to each other. And then the last one that we have on this set of problems right here are the supplementary angles. And the supplementary angles, remember, are the ones that add up to 180 degrees. I have two answers for that. I have angle 4 and angle 5, and they do make that straight line right there, so that makes sense. The other answer that I put here was angle 1, 2, 3. Can those three angles be supplementary? Well, the first question is, do they make a straight line? And they do. But remember that supplementary can only be two angles. So I'm going to make a note here. Can only be two angles. So we're going to take out angle 1, 2, 3 and just leave it at 4 and 5. Let's jump down to the last set on this page. All right. On the bottom of the page here, let's first talk a little bit about these questions right here. It says all angles can be named with how many letters? And remember, that is 3 letters. The middle has to be the vertex. Oh, and there's my second question right there. The middle letter is always the vertex. Those are really good things to think about. That's something that makes sure that you know that for the test. Those guys right there. Now these next guys on this side over here, we're going to be doing the complementary angles. Remember, complementary, 90 degrees. Supplementary, 180 degrees. Adjacent angles have to be next to each other. So if I'm looking at my picture over here, what 3 numbers will add up to 90 degrees. For sure it can't be the 128, so does 52 plus 38 make 128? And it does make 90 degrees, so that means that our two complementary angles would be angle B, only one angle there, we can name that angle B, and then angle BDC. That guy right there, BDC, that makes 90 degrees. Let's erase that and start over. The next question that we have is the supplementary angle question. Remember, those have to be 180 degrees. And again, we're looking for two numbers that add up to 180 degrees. For sure, I think we're going to use this 128 then. What would be the second number that we would put with 128 to make 180? And I do think it would be 52 if I add that. 128 plus 52, 0, carry 8, and there it is. So I need to name those two angles. This guy right here and this guy right here. To name those two angles, I would call that angle B and angle BDE. Then the last one are just any two angles that are next to each other. And so remember, they have to have a common vertex and a shared side. So here is my vertex and a side. There's nothing next to angle B. But if I look on this one, here's a vertex and a shared side. And notice I have a point on the left and a point on the right of that. So my two adjacent angles are going to be those two angles right there, which would be angle BDC and angle BDE. BDC and BDE. Noticing D is the vertex right there, and D is my middle letter on each of those. We're going to pause this guy, and we're going to jump on to the last page and see if we can get finished. All right, this last set of practice problems, we're going to be finding some angle measures and then setting up some equations. Right here I have a little hint for you. It says write an angle measure on the picture as you find them. So in this example, notice that we're going to be finding lots of angles here, and as we find something, make sure that we write it on the picture, and then we can fill in our answers. So when we look at the diagram, a couple things that I want you to notice. I like vertical angles because they point at each other, and they're always equal. So the first thing I would notice would be these two guys right here. Do you see the 142 and the C, how they point right at each other? That would be the first thing I would fill in, a 142 right there for angle C. And then I would think about straight lines, and I notice here that I have a straight line, and those two angles right there have to always add up to 180 degrees. So I have 180, take away the 142, and that's going to give me 38 degrees for angle A. And so I'm going to put my 38 right there. And then we talked about those vertical angles that point at each other. That makes this guy right here and this guy right here my next set of vertical angles. They point right at each other, and that makes angle B also 38 degrees. So we have everything on the left-hand side all filled in. Now we're going to jump over to the right-hand side. So a couple things that we can notice here. Now I see that I have a 90 degree on this side, so I'm thinking that if this side is equal to 90 degrees, doesn't the other side have to also equal 90 degrees because they make a straight line there, 90 on both sides? And then I notice, well, I have this angle right here, 53. it has to go with D, and that has to make 180. So when I add those together, or subtract them, I guess, 90 minus 53, borrow 37 degrees. That guy right there, angle D, has to be 37 degrees. Then we talked about those vertical angles again. So if I take this angle right here, and I look at that angle, and I take this angle right here, my 37 that I just found, do you notice that those two guys point right at each other? So that 37 that I have up on the top has to be a 37 down on the bottom. That makes that angle F 37 degrees right there. The last angle we have is angle E right here. And if you notice again, vertical angles, this angle right here, E, points right there at the 53. If I bring that in, do you see how those two guys are going to point right at each other? That means angle E has to be 53 degrees. Lots of ways of getting through a problem like that. But that would be a good one that you would want to study for your test, because I think you might see parts of that on a test. Not necessarily a whole thing, but parts of it. Now, let's pause and let's get into some equation mode here. All right, for questions B and C, we're going to be setting up an equation. It says set up an equation and find the value of x. Find the value for each equation. We're just going to focus on setting up these problems. Same with C. Set up an equation and find the value of x and y. So, to look at the first problem letter B here, it says what kind of angles are shown? Well, I notice that I have this straight line right here, and I have a shared side between them. Those are adjacent angles. But they also make this straight line right here, and adjacent angles are sometimes a linear pair. That means that these two angles together have to make 180 degrees. If I add them, I will equal to 180 degrees. From there, we could do like terms, and we could solve that and find out what x is. For letter C, we actually are going to kind of do the same thing. We're going to set up an equation and to find the value for x and y, and then they ask us to star the equation that we must solve first. Again, remember, we are only going to set up equations for this problem. We're going to leave the solving for later. What I notice on this picture is that we have these intersecting lines, and the intersecting lines, those are the ones that make your vertical angles. Those are the ones that point at each other. When you're looking at these problems, remember that you want letters that look alike to go together. So I do notice that I have these two as both x's, and so I would first think of a way to put those together. And when I look at that, do you see the shared side between these two angles? Those guys right there make 180 degrees. So I would write, like we did in B, 3x plus 8x plus 26 equal to 180 degrees. Then I would think about these angles that point at each other. And those are what we call our vertical angles. And remember, we said earlier that those are equal. So I would write 5y plus 38 equal to 8x plus 26. And so the first one, we had a linear pair. And the second one, we had vertical angles. The question says, which equation would you have to do first? It says that they want us to star that. And for that question, I would say you would need to star the first one because that is the one that has only x's in it. And so that one would need to be done first. Once you solve that and find out what x equals, then you can put that value right there, and then you'll be able to solve for y. We can talk more about that in class if you have questions. Let me jump ahead here to the last question. The last question says that two angles form a linear pair. The measure of one angle is 4 times the measure of the other angle. Find the measure of each angle. So if we're going to use our cubics, we're going to circle our numbers. So we have two angles. We have one angle that is 4 times the measure of the other angle. Then we're going to underline our question. The question says, find the measure of each angle. Then we're going to box our important words. And it does say that we have a linear pair. And it does tell us that we're going to do some times right here. So now we have to draw a picture. Well, when they say linear pair, the first thing I would do is draw that linear pair. And it talks about two angles, and that makes sense. There's one angle and there's two angles. And then the second sentence says the measure of one angle is 4 times the measure of the other angle. One of those angles is larger than the other. How large? It is 4 times as large. That tells us that one of them is going to be 4x and the other one is just going to be 1x. It is 4 times as large. Multiply times 4. And then we think back and we realize, oh yeah, these are a linear pair. And a linear pair make a straight line. And a straight line is 180 degrees. So I have the equation 4x plus x equals 180. Find the measure of each angle. I'm going to solve this now. 4x and 1x make 5x. Divide by 5. And it turns out that x equals 36. How does that go back into the picture? Well, if x is 36, that means this angle right here must be 36 degrees. And if the other angle is 4 times x, that means that the second angle must be 144 degrees. And then I just double check that. Does 144 plus 36 make 180, which is what my linear pair says? And it does. So there are the two angle measures, 144 and 36. Good luck on your homework, and we can talk some more in class.